Hello, welcome to another in the series of the AFRY Clean Energy webinars, and today we're going to talk waste to energy. Of course, we have some discussions within AFRY about the definition of clean energy that are often ongoing, and I think waste to energy is a very important part of that story, and definitely the story of sustainable energy. So I've got three colleagues with me today who are going to present for us and take us through both the commercial and the technical aspects of waste to energy, and particularly looking at sort of thermal incineration. But we'll get into all of that. My name is Matt Brown. I am Vice President in the Management Consulting Division, and I have spent pretty much all of my life working as a consultant on the energy environment interface. With that, I will hand it over for my colleagues to introduce themselves. Please feel free to throw your webcams on as you do.
Yeah, hi, thanks, Matt. My name's Lloyd. I'm a senior principal in the Management Consulting Division. Among other things, I tend to look after our commercial and market advisory activities for the waste to energy sector, particularly in the GB, but also other markets. So that's me. Peter?
Yeah, my name is Peter Kling. Good morning. I'm in charge of the waste to energy consulting at the AFRY company, working the global market, being involved in this business already over 30 years. And I have a true passion in this waste to energy issues. Helen?
Okay, good morning. My name's Helen Moon. I work in the thermal and renewable department within AFRY as a principal engineer. I joined AFRY in November from Viridor, where I was project manager for the delivery of 3 energy from waste plants in their portfolio.
Lovely, thank you. If we can just touch upon a little bit of housekeeping, and that is that we encourage everyone to ask questions throughout the webinar. We will cover as many as we can at the end. If we don't cover them, we also will have a look through and try and get back to as many people as possible with responses to those questions. The slide pack and recording will be emailed out, and the back catalogue of all of the webinars are available on the website. You just have to search the internet for AFRY Energy webinars and you'll find them. And as a slight plug also, you could search for our podcast series there as well. With that, I'll hand over to Ali, who is going to take us through the first section. Thank you.
Okay, thank you, Matt. So we've split the webinar today into 2 sections before we get to questions at the end. So I'm going to spend a bit of time just giving an overview of the waste to energy sector and why it's interesting for many of our clients as an investment opportunity. And then I'm going to hand over to Peter and Helen to talk about some of the technical challenges of building and operating waste to energy facilities. And it's worth saying the 4 pictures you can see on the right there are all facilities that we have built. That's Peter and his colleagues, so he can answer questions on those. Okay, so I think we're all familiar with the idea of the waste hierarchy. And after we've reduced, reused and recycled as much waste as possible, then we're still left with a residual waste stream. And the next best thing to do with that is to recover energy from it. And that's the focus of today's webinar. And that's preferable to the final option, which is disposal, normally to landfill. For the purposes of today, we're focusing on thermal treatment of waste. Excuse me. There are other energy recovery technologies available, such as anaerobic digestion, but we're not covering that today. On the right-hand side, I've just given a flavour of some of the typical volumes in Europe and what happens to the waste in Europe. This is Eurostat data from 2018. Total waste across the EU is well over 2 billion tonnes, but a large portion of that isn't of interest for today because it's non-combustible waste, such as construction waste and mining wastes. Over 200 million tonnes a year of municipal waste is generated, so that's waste that's collected by local authorities from households or small businesses. And broadly speaking, a similar volume of waste is collected directly from commercial and industrial customers, so that's C&I waste. And the composition of that is broadly similar to municipal waste. And of that waste stream, in 2018, around 45% was recycled, and that includes composting here. Around 30% was sent for energy recovery, and most of that will be in waste to energy thermal treatment facilities. And then the remaining 25% or so was disposed of, mostly in landfill. A very quick overview of the key policy and legislation that drives waste. The top two directives are to do with what you do with waste and how you move it. And then the bottom two are about essentially how you burn it in waste to energy facilities or in incineration facilities. So starting at the top left, the landfill directive has been very successful in reducing the amount of waste going to landfill. So the landfill directive is all about definition and regulation and operation of landfill in a safe manner, but it also sets targets for diversion of biodegradable municipal waste away from landfill. These were updated in 2018, and the latest target now is that by 2035, the amount of waste going to landfill should be only 10% of the level that it was in 1995. And that landfill diversion has been the big driver of the growth of waste to energy in Europe. The Waste Framework Directive on the top right is the document that actually steps out the waste hierarchy we saw on the previous slide. It defines what is a waste, what isn't a waste, how waste should be moved, both within a country and across borders. It also sets recycling targets, and again, these have been updated recently. So the latest target is that by 2035, 65% of household waste should be recycled. And this document also defines what counts as energy recovery, and it refers to this thing called the R1 efficiency criteria for an energy from waste facility. So energy from waste can only be considered as energy recovery if it meets certain efficiency targets. The Waste Incineration Directive is the directive that sets out the technical criteria for how to combust waste in a way that minimizes the impact on the environment. The key element there is this criteria that waste must be kept burned at a temperature of 850 degrees or above for at least 2 seconds, and that influences the design of these facilities. The Waste Incineration Directive was updated and absorbed into the Industrial Emissions Directive in 2010, and that document is the framework for regulating all emissions to land, water and air from these installations. And most importantly, it sets emission limits for facilities, and these, generally speaking, have tightened over time, and the latest reference document that defined the best available control technologies was updated in 2019. Okay, so moving on, This chart, the chart on the left, shows that although the total volume of municipal waste has remained broadly steady over the last 25 years, the landfill directive has in fact been very successful in diverting that waste away from landfill. And you can see that that diversion has resulted in significant increases in recycling, composting, and in incineration. And so, as I said, the landfill directive has really driven the growth of energy from waste across Europe. And you can see that on the right-hand chart that shows the evolution of capacity over time. So now we've got over 150 million tonnes per year of waste to energy capacity. And it's worth noting that that figure is higher than the 90 to 100 million tonnes in the chart on the left, because most of these facilities burn a mixture of municipal waste and commercial and industrial waste. But it's worth saying that although it's been, looking at Europe as a whole, it's been a success story. It's certainly a mixed picture across different countries. So as I was saying, generally speaking, the waste to energy has made most progress in Northwest Europe. In other parts of Europe, there's still significant amounts being sent to landfill, which shows that in those particular markets, there is potential for more build out. In the more developed markets, rather than building many new facilities, I think the focus will be on refurbishing and replacing facilities as they age, and some of these facilities are getting quite old in some of these markets. This is the same chart, but I've also added onto this recycling rates, just to make the point that generally speaking, high recycling and high waste to energy have tended to go hand in hand as landfill volumes have been diverted away from landfill, that's generally led to kind of more segregation of waste at source, which helps you recycle more, and then the residual waste stream can be sent to a waste to energy facility. Okay, this slide just shows a few headlines from the trade press about investments that have been made in the waste to energy sector in recent years. And recent years have seen probably a pickup in activity, particularly of financial investors coming into the sector. Many of the original facilities were built either by specialist waste management companies or indeed by municipalities themselves, but these are very capital intensive assets, and there's definitely a role for third party finance to come in and help get these facilities built. And from an investor point of view, they can be attractive investments. They tend to be long-term investments, and that suits a lot of the kind of infrastructure fund, pension fund money that's looking for long-term investments. And generally speaking, a lot of these facilities are underpinned by long-term waste supply contracts with creditworthy public sector counterparties. Having said that, there are still a lot of risks that need to be understood for investors looking at investing in waste to energy. In this chart, I've split those into three broad categories: feedstock, technology, and energy offtake. And the feedstock is in some ways quite a unique feature of waste to energy. Generally speaking, it has a negative price. You actually get paid to take the waste, but compared to investing in in a renewable solar farm or wind farm, that has no fuel, the feedstock introduces a whole new category of risks. The first question is, where is the waste going to come from? Is there enough of it? Some of the waste stream might be underpinned by a long-term contract, but increasingly, some of the waste stream is not. So it's important to understand where that waste is going to come from, who else in your regional catchment area might be competing for it, or indeed, are you competing with movements of waste further afield, for example, exports? In addition to worrying about the volume of waste, you need to pay attention to the actual quality and composition of the waste. It's a very variable fuel. The CV can vary, the composition can vary, and that poses a lot of challenges for the technology that we'll hear about shortly. And because these are very long-term assets, both the availability of waste and the composition of it could well change over time, particularly as a result of future changes in waste policy. So if we have more recycling, what does that do to the waste stream, et cetera, et cetera. We'll hear more about technology in a moment when I pass over to Peter, but it's worth saying that particularly because of the nature of the waste, that introduces a lot of challenges to design these facilities, make sure they comply with the environmental criteria that we mentioned earlier. And then finally, around half the revenue of the facility will come from selling the energy, with the other half from gate fees from the feedstock. So it's important to understand the power market that you're selling into. How do you actually sell into the power market? What do PPAs look like? Are there additional revenue opportunities available for electricity? So in the UK, for example, that could be capacity market or guarantees of origin or embedded benefits or even private wire supplies. And many of these facilities are also ideally situated to provide heat, either to industrial facilities or to district heating networks. So there's an additional revenue opportunity there. So that was a quick summary of the why waste to energy is an interesting sector for our clients. And with that, I'm going to hand over to Peter, who's going to go into a bit more detail about the technology itself.
Very good, thanks. So let's move on to the technological part. And well, we start to talk a little bit about the basics. We have many kinds of thermal treatment technologies in the market, but there is certainly the most common one is the technology based on the great boiler technology. I would say something like 90% of all the facilities that has been built up until now are based on the great furnace technology, meaning that it has a lot of references. It's really designed for heterogeneous waste, meaning that it has to be a very robust thing. Doesn't necessarily need any kind of pre-treatment, and there are some upsides also, that you can use the metals coming out from the grate, from the slag. You can sort it out and use that. What is very important when we are talking about waste management and thermal treatment is that you can reach very high availability. That is a very important factor. And the space requirements, they are not that substantial compared to competing technologies that require a pre-treatment facility. So but then the downsides are that you operate with a relatively low steam parameters, meaning that if you only want to produce electricity, then you have to accept that the steam parameters in our cases where we have been involved, the highest steam parameters have been something like 450 centigrade, 76 bars, but and then if you want to go even higher, then you need some special materials for that. Then because of the rather heterogeneous material, they have a high slag amount coming out from the grate, and this is definitely not a multi-fuel boiler, so it's difficult to co-incinerate conventional fuels like coal, peat, etc. But we can move on to the next slide. Other technologies, so the second, let's say, alternative technology for the grate is based on fluidized bed combustion. Something like 5% of the facilities that are built until now are based on this technology. And the benefits with this is that if you have a circulated fluidized bed boiler, you can reach higher steam parameters, let's say compared to a grate furnace. So in our cases, it has been something like 500 degrees and 85 bars coming out from the boiler. If you have a bubbling fluidized bed, then the steam parameters are rather comparable to a grate furnace. We are talking about 420 and 40 bars. The good burnout of ash is one upside of this technology, and this is really a boiler for multi-fuel cases where you can co-incinerate coal, peat, wood and sludge. But the downside is that you need an expensive and sensitive pretreatment. You need more space for that, and the availability figures are not that good as you have had in the case of a great boiler furnace. We can move on, and then there are the third one which I wanted to take out. We have actually references of all these various kind of technologies. This is the gasification. This is an example of a true gasification plant, meaning that we are gasifying the waste and producing gas, which we then burn in a gas boiler. And there you can really reach high steam parameters. In this case, for 540 centigrades and 120 bars, and this makes the investment competitive if you already have an existing gas boiler there. The downside is that you, as in the earlier case, you need an expensive and sensitive pretreatment, and this cleaning of the product gas is not yet a commercial technology in the sense that you could only use municipal solid waste as a fuel. You have to combine or operate the plant periodically with cleaner fuels in order to clean up the hot gas purification. And in the market, we have a limited number of references and suppliers. And the next slide shows you one of the cases where we are treating the municipal solid waste with this multi-stage pretreatment plant. And this is necessary that you take out the piece, material piece sizes has to be suitable for the fluidized bed, and also you have to take out components like metals and meaning magnetic and non-magnetic metals and glass stones out from the waste in order to have a trouble-free operation of the plant. What I wanted to highlight here is that the purification of the flue gases, that is the other challenge what we are confronting with, but for all these three technologies I just went through, we have the same, let's say, challenges, but we have good technologies in the market that can match these requirements, cleaning the dust, acid gases, toxics, nitrogen oxides, and heavy metals. And there we see that there has been a huge development in the market from the earlier stages where the flue gas purification was as big as the rest of the plant to, let's say, more simple and feasible solutions. Then I think, Helen, you will continue.
Yes, thanks, Peter. So as Peter has introduced the sort of main technology for the core of the energy from waste plant, so the combustion element and the boiler element, we just wanted to talk about a few points to consider around the rest of the energy from waste plant. So really, critically, energy from waste plants are really long-lived assets. They have a plant life of between 25 and up to 40 years. And over that time, there might be variations in the waste quality, quantity, and so you might have varying calorific value, moisture content, and ash content. So you really want a really robust energy from waste plant so that it can adapt to any future changes. So we've seen over sort of the recent period, especially in the UK, that a number of energy from waste plants are applying to increase their capacity on their permits to allow them to process more waste throughout the year. This means that they're either operating above 100% for the majority of the year, so they've got a very good, reliable plant, or their availability is higher than expected, or perhaps they're taking lower calorific value waste so that they can process more. So you really want to have a robust plant to be able to support that sort of increase. Another issue that we look at carefully is the superheater materials. So the superheater is the hottest part of the boiler. It's where the superheated steam runs through the middle of the pipe, and the pipe is sitting in the flue gas that is has corrosive properties, so that it has a really hard life, and therefore the material of the superheater and the selection of that material is really key for the availability of the plant in the long term. Because if you have a superheater failure, so a hole form in that tube, you would have to bring the whole plant down, cool it down, access inside the boiler, carry out the repair, and then start the plant back up again. And starting an energy from waste plant isn't an instant thing. It has to warm up gradually over a day or 2 days even. So you really want to avoid those type of failures. Another important factor to consider is your waste storage capacity. So normally in the UK we see waste stored in bunkers at the sort of entry of the plant, but you can always also have silos for pre-treated waste. And the amount of capacity of waste that you can store is really important for the smooth operation of the plant, because you need to be able to store enough waste to get you over periods where you don't have waste deliveries. So perhaps over Easter holidays you have limited waste deliveries, so you want to be able to store enough waste up to continue operating. And also the reverse, so that if you have a unplanned downtime of the plant, the waste that's already on the road and due to be delivered to your plant can be delivered and tipped in the bunker, and so your customers don't see a disturbance in the sort of in their service that they're receiving from you. And critically, you also keep the receiving the waste fees, gate fees. In the ability to bypass the steam turbine generator is also an important aspect of having a flexible plant. So in your waste to energy plant, you normally only have one steam turbine generator, and therefore if there's an issue with that and it trips, then you want to be able to continue processing the waste while you sort out that issue, so that you can continue earning the waste gate fees and then bring the generator back online as soon as possible. An additional factor, and really a key factor in the successful operation of energy from waste plants, is the waste or the waste fuel quality, and how you control that. So from my experience, I believe this is really done by good communication and education of the people that are delivering waste to your site. So if that comes from a waste transfer station, the people who are loading the trucks up need to understand what is unacceptable waste, so that you don't receive deliveries of large oversized items or gas canisters that could potentially damage your equipment. And so it's communication and educating those transfer stations and potentially the council workers as well. So that is really key part that needs to be considered. An O&M approach is really similar to the different considerations you might have to any power station, whether you have a preventative maintenance strategy, what strategic spares you hold, and your replacement of key items. But it's something to consider over the lifetime of the plant. And as Ali briefly touched on, emissions, so it's a key area in energy from waste plants. We do have very strict controls on the emissions that can be released from the plants, and they're very well controlled. But it's a good idea to ensure that you have sufficient space on your site to allow potential retrofit of any future technology that might need to be installed to allow, a robust plant. Okay, can we go to the next slide? Thank you. So sort of after covering very briefly some technology sort of based points, we briefly wanted to talk about the contracting arena and some of the issues that have been experienced, especially in the UK energy from waste contracting strategy, contracting arena. So as you can see on the right, there's been some really serious issues in the construction of energy from waste plants, which unfortunately has seen some of the contractors go out of business, which is not good for anybody. And so those sort of scenarios really need to be avoided. So how do we avoid them? It's really about setting up your contract and your project in the best way possible to minimise those risks by considering what's the best contracting model. So traditionally in the UK, we've used EPC type contracts where you just hand the whole construction of the whole plant to one contractor, and in that all the risk goes to that contractor. But then we've seen that if they could go out of business, and that's left significant issues for the client. So an alternative strategy is an EPCM model where the plant is broken up into its major components. So you would let contracts for the main combustion technology to one contractor, the steam turbine technology to another contractor, the civils work to another, and the balance of plant to maybe one or several. And if you're going to go that way, you obviously need somebody to integrate those contracts and make sure that you have a successful plant at the end of it. So you need what's called an EPCM consultant or contractor, of which AFRY is one, who has had some success, especially in Northern Europe. And it's this sort of contracting model is attracting much more interest in the UK as well, as it gives a lot of control. So if you do have issues, the client has a lot of control into how those are sorted out. When you're placing a contract, you really need to consider the normal sort of things you would consider, which is what's the track record of the technology supplier? Is the technology proven at scale that you're looking at? And is it proven with the waste quality and composition that you have? That is really so important, because waste is a difficult fuel, and so your technology needs to be robust. And then contractors, what's the capability, what's their capacity, and what's their track record in energy from waste? Are they aware of all the interfaces that need to be managed with the various sort of fire regulations, insurers requirements, ash handling, waste handling, the building services? All these sort of support contracts have also a great importance. So the contractor really needs to be aware of those issues. So finally, it's been a very quick run through of what is a really big industry. But from my point of view, I think the key to a successful project and a successful plant is really making the right decisions in the project implementation, not just for the delivery phase, because that's only sort of 3 to 5 years, but for the whole lifetime of the plant, so the 40-year lifetime. So you want really a good proven technology and a robust plant that can adapt to the changes that you might have in the future. Okay, thank you.
Lovely, thank you very much, everyone. So we're going to move on to some questions. I think we've got quite a lot of interesting ones that have come in. So let me just ask the first one if I can. So I've got some suggested options. Right, yeah, here. Ali, maybe you could answer this one. If recycling rates continue to improve, will there be enough residual waste for existing facilities?
Okay, yeah, that's a good question. And the answer is not necessarily. It's important, I think, for any facility to understand, for that particular facility, what's the outlook for the supply and demand of residual waste in its locality. And so typically you would look at a local or regional level, although you do need to consider movements of waste further afield, exports, etc. So the supply of waste, if you like, or residual waste, is driven by factors such as, what's happening to recycling rates. The demand for waste, if you like, is about, what are the competing disposal routes for that waste. So obviously there's landfill. What are the other waste to energy facilities that, in your region that, might be looking to use that waste? And I think over time we might see the emergence of more alternative uses for waste as well. There's growing interest in waste to X technologies, and that's converting waste to things like transport fuels, road fuels, or aircraft fuels. And I think over time that will become more significant.
Thanks very much. Helen, Peter, anything to add on that one?
Go on.
Yep.
You go ahead, Peter.
Okay. No, I would just like to say that the circular economy industry that is very much seen as an alternative for thermal treatment. But as Ali told in the beginning, this recycling technology goes definitely hand in hand with the thermal treatment. So when you produce new products and recycle and further, let's say, develop that business, you all the time you get a huge amount of byproducts, and the thermal treatment is definitely the answer to that. Helen, you had some.
Really, it was really a point on the emerging technologies, and some of those are at very early stages of waste to fuel, etc. And there's a lot of waste around at the moment that needs treating. So while those more novel technologies are being developed and proven at commercial scale, you still need some way of treating the waste for the foreseeable future while those are being proven, I would say.
Thanks very much. I just really one question from me. I don't know who could answer it, which is there's a lot of focus on plastics and people not using plastics currently. Has there been any noticeable reduction that you're aware of in the waste streams for municipal solid waste? Is there a reduction in plastic? I know, Helen, you said there you've got quite a large sort of boundary area in which plants have to operate to be able to cope with variations in calorific value. But have we seen, is anyone aware of it? Have we seen anything yet? Any impact of this focus on plastics, or is it not really discernible yet?
No, you do see the variation in across different councils, because different councils have different recycling sort of methods. And so the quality of the waste varies depending on the recycling regime that each council has. But it's not just plastics which have a high calorific value. It's also, if you have food waste separation, food waste is quite a wet sort of wet thing, and so that would lower the calorific value. So if you have a separate collection for food waste, then that would increase the calorific value. So it's a whole, looking at the recycling as a whole, and what is the residual waste left that you need to deal with.
Okay, thanks very much. Another question, probably Ali, maybe you could start and then please join in, which is about how sustainable is waste to energy then if it's producing carbon dioxide emissions? Where's that headed?
Yeah, so it's a good question. So at the moment, the biogenic fraction of waste is defined as renewable under European legislation, and that's typically around 50% of the energy content. Waste to energy facilities are not currently covered by the EU emissions trading scheme. So there are carbon emissions associated with the fossil fraction of the waste that isn't covered by the ETS scheme. That could change in the future. It wouldn't surprise me if the scope of the ETS changes and waste gets brought in at some point. And there's also an emerging debate around incineration taxes, for example, whether you should impose those to try and incentivize diversion of plastics, for example, away from residual waste. So I think there's further developments to come. I think it is important to understand that what you don't want to do is make waste to energy less attractive than landfill, because from a greenhouse gas emissions point of view, waste to energy is a much preferable solution. But I think in the longer term, there will be questions about how you control, the CO2 emissions from waste to energy facilities. Peter, I don't know if you want to talk about CCS and carbon capture.
Yeah. Definitely these waste energy plants, they want to follow the trends they want to see in the future. They want to develop their businesses, and there is actually a network of various plants globally that are making pilot tests and have big plans for the future to come up with an answer. So we are talking about carbon capture storages and carbon capture systems that will be applied to these waste energy plants. So in this network, what I know also, we have Norway, Netherlands, Sweden, Finland, and some countries in some cities in Japan and also in UK we have plants that are participating in this development of the business. So I see that in future we will definitely have plants where we have combined the carbon capture with a waste energy plant.
Anything else to add, Helen, from your side on that?
No, I think Peter's covered it.
Yeah. Okay. So carbon capture, storage, you know, could be the long-term solution. What else could be the long-term solution? Just recycling everything? Is that right? And not burning anything? Is that possible, or not really?
It isn't possible, because you will always have something that you can't recycle, because otherwise you would have an infinite number of recycling plants for every different type of waste that there is. So you really need to focus on those that you can recycle, and then even with the recycling plants, they all, as Peter said, produce a byproduct which needs to be treated somehow. So there will always be a place for sort of residual waste treatment.
Okay, thanks very much. I think I'm looking through the questions on the that are up. I think a lot of them were around the CCS issues and whereabouts CCS is taking place. I think you've covered that, Peter. Where the pilots are moving forward. There's a question here about typical fire risk when processing the material. Any thoughts on that? I know, you know, when we talk about the wood pellet, the biomass plants, then fire risk in the storage of the fuel is an issue, but I guess with waste less so, not really an issue there.
Well, it's a power plant, so there's always a fire risk, but there is very strict guidance on what fire prevention and protection measures to install in these plants, and fires are very rare in energy from waste plants. Waste fires are more typically seen in waste transfer stations and things like that. So yeah, where they're handling a large amount of waste, and the issue of lithium ion batteries causing waste fires in those transfer stations is a significant issue in the UK, and a subject in its own right. But energy from waste plants, the waste is contained in a bunker which has fire sort of suppression if there is an issue, but it's very rare.
Okay. Good. I can see that we're slightly over time, and I'm sure people have their next calls to jump on, as we all do these days, the team calls. You can contact us directly. I think there's some interesting questions still remaining, so we will have a look through those, as I say. But please do reach out to any one of us for more information if you want to find out the projects that we've been involved in on the EPC side, or other projects we've been looking at and helping with, then happy to fill in more details, more information, I'm sure. And with that, I'd just like to thank very much Peter, Helen, and Ali for contributing today. I hope you enjoyed the session, everyone, and look forward to the next one. Cheers. Bye bye.
Thank you.
Thank you.